starts the graphing of quadratic functions. The first thing you're going to notice about these graphs is that they look very different than the linear graphs we have been doing because of a special shape these graphs will take on, which is called a parabola. Also, the quadratic function has a standard form. Y equals ax squared plus bx plus c, and a cannot equal 0. So we will be using those two pieces of new information to be working on this graphing. One other thing that you want to take note of is that if the leading coefficient, that means the a here, is a positive or a negative. So if the leading coefficient is positive, you're going to have a parabola that opens up. If it is negative, you're going to have a parabola that will be facing downwards. There's also one other term that you want to be aware of, and that is I have to find it here real quick, the axis of symmetry. Right here is the axis of symmetry, and we will be using a formula to find that as well, and that is the point that makes the mirror image of the parabola on each side. So in this positive one is right there on the y-axis, and we're the same place here on this one. It does not always have to be on the axis though. Okay, so we're going to start with example 1, which is going to be graphing a quadratic function that has a positive a value. So we know that our parabola is going to be facing upwards. All right, it says sketch the graph, and here is our equation. The equation we're going to be working on is y equals x squared minus 2x minus 3. The first thing that we want to do is we're going to find the x coordinate of the vertex when a equals 1 and b equals 2. To do that, we're going to put that into the equation negative b over 2a. Right here. So I'm going to go ahead and my equation again, I'll move it down here so it's a little closer to see. My equation is ax squared plus bx plus c. So I'm going to go ahead and I'm going to look for my a value, which is right here, and since there's not a coefficient, it's an implied 1. So my a value has become 1. And I'm going to look for my b value, which is the coefficient to the second term, which is a negative 2. So that is my b value. When I substitute those values in and I solve, I will get negative 2 over negative 2, which gives me the coordinate point of 1. So when I look at my my parabola, which is already finished in this case, but you can see that I have my line of symmetry, my axis of symmetry, sorry, I got a little carried away there, axis of symmetry is on x equals 1. The next thing that we will have to look for is the other points on the parabola. So we know that's the line, the axis of symmetry, and now we have to solve for the others. Now we're going to again look at the form that we have here, ax squared plus bx plus c, and for this particular equation, our equation is going to be y equals, and let's see, that was x squared minus 2x, and that was again a negative 3. It's an open one because our coefficient here is positive, it is open up, and then we will go ahead and we will try to see if we can find some of the other values. So we need to find y when we substitute these values in. So to figure out our first coordinate point for y, we're going to substitute negative 2 in. So y equals negative 2 squared minus 2, again our x value is negative 2 in this one, and minus 3. I'm just substituting in x and y values. So negative 2 squared would be 4, negative 2 times negative 2 is plus 4, and then we're going to go ahead and subtract 3. So we have 8 minus 3, so our y value would be a 5 there. Okay, let's go ahead and do the 0, 1 mentally. The 0, 1 would be 0 squared. Okay, and 0 squared minus 2 times 0 is 0. And so our coordinate point there would be a negative 3. I think you're getting the idea here. So I'm going to just fill in those other ones. We're just substituting in our value of x into this equation here to find our different coordinate points. All right, I'm going to move that though if I can. Move my equation over just a little bit here. How about if we put it there? And let's fill in the rest of our chart here. You can see that chart on the coordinate points that are graphed already, but I'll go ahead and give you that visual. Negative 4, negative 3, 0, and 5. And those are in your books. I wasn't figuring those out quite that quickly. Now once you have your points, then you can go ahead and plot them, and when you connect them, you will see that you have that parabola with the axis of symmetry on x equals 1, as we said, and it will be opening upwards. The next quadratic function is going to be with a negative a value. So the negative a value is located right there. So we're going to do the same type of equation. The first thing we're going to do is find the x-coordinate of the vertex. And we're going to do that by substituting our a and our b into that negative b over 2a. And so let's substitute in our a and b value. Our b value this time is a negative 2. And our a value is, did I do that backwards? I think I did. Got ahead of myself there. I did that on the last recording and then I didn't save that one, so I want to go back here. Okay, so a negative b, and this time our b value, here is our a value, here is our b value, and our b is an implied 1. So we have a negative, negative 1. And then our a value is a negative 2. So a negative, negative 1 would be a positive 1, and 2 times negative 2 is going to be a negative 4. So we have a line of symmetry at a negative 1, 4. Now, if you look at that, we have our x value as negative 1/4 at this point here, and that is our axis of symmetry for this parabola. My goodness, parabola. So then we went ahead and we're going to again substitute in the x values to come up with the y values. And you want to do values that are to the left and the right of our line of symmetry. Now, notice the study tip over here that says that the x-coordinate to the vertex is a fraction, but you can still choose whole numbers when you make a table. So you will have to figure out that one to make your point for the axis of symmetry. However, you can use whole numbers for all of the rest of those values for figuring. Once you do that, you can plot the points, and because we had a negative a value, we should have the parabola facing downwards. Now I do want to show you this little button here that is in your textbook online. If you're using the textbook online and you come to one of these interactive buttons, you can click that and you will also get another little video. You will need a plug-in that you might have to install on your computer. So then our second goal is to use this in real life. And so we're going to do the same kind of process as we did in example 1 and 2, but this time we're going to talk about air resistance. And to make it pretty simple, we're going to use the path through the air that can be approximated by a parabola. So we'll go to track and field, and we have Natalia that's holding the world record for women's shot put. And the path of her world record-breaking throw can be modeled by, and this should look familiar to you, it looks like a quadratic equation. Okay, we have a term with an x squared, this would be our a. We have a term with just an x, that would be our b term, and then we have just a constant term, which would be our c term. So we're going through the same process as we were before. We're going to figure out where our axis of symmetry is by substituting in our b and our a values. and then we're going to go ahead and we could make a chart. I believe I have on the next page. We had a negative value, so the parabola is facing downwards. Here is our chart. And so we're doing the same thing, and then we can use that chart to find what distance that the shot put hit. So the same routine as we did before, you can pause this and click back and forth between the two slides to see how we